All right, let's do this on your own first, okay? And check with me. All right, predict the type of interaction of each of these compound, and then rank the boiling point highest to lowest. Okay, so start with step number 1 here. So in A, what do you guys see? So first of all, I see oxygen. This guy can do dipole, of course, right? So oxygen partial negative, carbon partial positive. All right, and they got carbon bond. That's a polar group. They can do London forces there. Okay, but in B, OH, you can see there's a hydrogen bond. Okay, and we get for carbons right here. There's a London forces. All right, C and D, same thing. So we have hydrogen bond donor right here, and we have London forces for the rest. All right, D, hydrogen bond donor, and the rest are London forces. All right, let's rank the boiling point here. Okay, so the lowest one, you can see that the A for sure, and B, C, D can form hydrogen bond. There's going to be they're going to have higher boiling point than A. Okay, now we have to rank B, C, and D. They all can form hydrogen bond, but the difference is the London forces right here. So we have straight chain, a little branch chain, very branch chain. Okay, so London forces depends on the surface area. The highest surface area, that's the highest boiling point. So we're gonna go B, C, and D. Okay, so B, C, D, and A. That's the first one. That's it. All right. Look at step number 2 down here. What we got? C double bond O right there is ketone. So we got dipole. Okay, and for carbons down here. So that's London forces. All right. In B, all right, OH, just like at the top one, same compound there. So we have hydrogen bond donor, and 4 carbons right here. That's a London forces. Okay. In C, what is this? Non-metal and metal. We got an ionic bond here. This is going to be real strong here. All right, ionic bond. And 4 carbons right here. That's the London forces. All right. And D, so we have nitrogen. And H2, this is another type of hydrogen bond donor. Okay, if you still remember, so F, O, and N, they can form hydrogen bond as long as they have a hydrogen on it, right? So there's a hydrogen bond donor, so NH2, and we have 4 carbon there. That's London forces. All right, how do you rank this? Of course, C comes first, that ionic bond. Okay, and B and D have hydrogen bonds, so put B and D in between. A has no hydrogen bond, put at the end, the lowest boiling point. Okay. All right. Now B and D, what's the tiebreaker? They both can form hydrogen bond. London forces, same London forces. Well, B comes first. Okay. Why B comes first? So if you look up the boiling point, so I look up this boiling point for you for an alcohol, 117. For nitrogen, this amine, only 78 degrees. Right. The real reason is the hydrogen bond of of an OH is stronger than the hydrogen bond of an NH. Okay, because of the difference in electronegativity between oxygen and hydrogen is higher than the difference in electronegativity between nitrogen and hydrogen. So this guy from hydrogen bond a bit better than stronger than the nitrogen. Okay, so we go B and D right there. All right. So a little bit about the application. So if some of you probably have watched the very first Spider-Man, the Tobey Maguire play, not the Amazing Spider-Man or the Spider-Man Homecoming, not Tom Holland, not that. This is like Tobey Maguire, the first one, first Spider-Man. So actually, I want to talk about even just a regular spider. You know that Spider-Man can climb walls, right? He can climb walls. How does that work? There was a scene that when he got bitten by the spider and he tried to discovered his power in his bedroom. There was a scene that they're looking closely to his hand, and it showed, what is it, like not a hair, small little hair on his hand, on his fingers. Okay, same with this hair at the surface area. Yeah, think about that. So we have a little hair right there at the surface area to his body, his hand, his body, his feet, and that's allow him to have stronger London forces to the wall. That's why he can climb the wall. right? But that's not really true. I mean, our body contains a lot of water. We're really heavy. This small surface area doesn't work actually, but he's superhero. Who cares? Okay. In the some animal use the surface area on his hand and legs, like in gecko. Okay. They that's why this guy can climb walls or can stick to the wall because of London forces. All right. All right. We have a little bit right here. So if you understand the concept of it. So we have these two compounds. If I want to dissolve these two compounds, what solvent should I use? What type of solvent should I use? Okay. If you still remember in Gen Chem 2 that dissolve right? Polar compound love to dissolve in polar solvent. Non-polar compound, non-polar solvent, if you remember that, right? So they can naturally, you can see always are London forces, non-polar. If you want to dissolve them, you're going to pick non-polar solvent down here. Pick any of this here work. Diethyl ether, hexane, toluene, benzene, carbon tetrachloride works right there. Okay, so non-polar compounds, non-polar solvent. Okay, all right. So we got this one. We have cinnamaldehyde. Okay, we have glucose. Now you see, glucose is really polar, highly polar. So 1, 2, 3, 5 OH groups. Right, so it's highly polar. So if you wanted to dissolve water, dissolve glucose, you gotta pick polar solvent. Right, so who's polar solvent? Up here, pick any of this work, and you know water dissolve glucose pretty well. Okay, so this guy go there. Cinnamaldehyde a little bit less polar, right? A little bit less polar. You can pick the second one right here. This one, medium polarity. So ethyl acetate, acetic acid work, THF, methylene chloride works. Any of this work. Okay, that should be medium polar compound. So medium polar solvent.